Hello everyone, my name is Yang Su and I'm a postdoc at Inhaye UVSQ. And today I will present to you my PhD work, and the title is the data-driven approach for assessing the productive performance of conservation agriculture. So first, I will give you a brief introduction of conservation agriculture, or CA. And later, we will discuss about the productive performance of CA under different farming practices and the different climate conditions. And at the end, I will show you a platform we created to help the local farmers to assess their productive performance of CA on the farm. So about the conservation agriculture, I assume everyone here knows it. So basically, it is a farming practice that aims to improve the long-term crop production while conserving the environment. And it has three principles. The first one is the minimum soil disturbance, or the no tillage, which can reduce the soil erosion, improve the soil structure, and reduce the fossil fuel usages. And the second is the permanent soil cover. It can increase the soil organic matter input and improve the soil fertility. And it can also protect the soil from erosion and decrease soil water evaporation. And the third one is the dynamic crop rotation, and it can increase the biodiversity level and reduce the stress from the pests and the diseases. Indeed, CA can bring a lot of environmental benefits, but the productive performance of CA is still under debate. There are a lot of studies have been published to tackle this problem, and some reported a yield increase from CA when comparing with conventional tillage, while the others reported a yield decrease. And moreover, the impact of climate change on the productive performance of CA is still unknown. So to address those questions, we decided to connect the data from the published papers. And we built this data set. It contains 4,400 pairs of yield data from different no tillage systems and conventional tillage systems. And we connected them from more than 400 papers. And those data covers 50 countries and includes 8 crop species, including barley, cotton, maize, rice, sorghum, soybean, sunflower, and wheat. And here is the distribution of the site experiment for those data. And then later we use different machine learning models to process those data, and we compared all those models, and we found that random forest has the best performance in predicting the yield increase or decrease from CA. And the final model is the final model performance of random forest is AUC is 80% of AUC value. And then we make the global projection, and here are the results that compares the productive performance of CA or NT versus conventional tillage. The bluish color indicates relatively high probability of yield increase comparing with CT, while the reddish color indicates a lower chance to have a yield increase or higher chance to have a yield decrease. And if you compare these two figures, we can see that CA has a better performance than CT. We also studied how farming practices will affect the performance of CA, and here we show that the left is CA with further fertilization and with the control of pests and the weed, and the right side is without fertilization and the control of weed and pest. and we can clearly say that the fertilization and the control of the weed and pest can boost the performance of CA. And if we see this, the figure on the left, we can see that with well-managed crop fertilization and the weed and pest control, CA can outperform CT in many regions for maize. And for soil cover, the left side is is basically CA or no tillage with soil cover, and the right side is no tillage without soil cover. And we can clearly see that soil cover has a very strong positive effect on boosting the performance of no tillage systems. As for the impact of climate change on the performance of CA, we show that here, actually the bluish color indicates the probability of yield gain is increased in the future, and the reddish color is decreased in the future. And here the future, here the current scenario we set is the average climate condition between 2011 to 2020. And for the future scenario is 2051 to 2060, the average climate condition. And here we show that maize in the future, the performance of CA will be improved in many tropical regions. So in those regions, if we want to apply conservation agriculture for maize, we can expect that there will be a better performance in the future. And based on, since the performance of CA is affected by a lot of factors like locations, climate conditions, farming practices. So based on the above mentioned studies, we build a platform to help farmers to assess the local productive performance of CA on their farm. So why we need such a platform? Because actually farmer is very important in implementation and adaptation of CA system. So with this platform, they can know more about CA, and they can also check the local productive performance of CA versus the conventional tillage system for different crops with different farming practices in different climate conditions. And the platform will look like this. It has a homepage. Basically, on this page, there will be a lot of general knowledge about conservation agriculture. And then we have the calculation page where you can set the parameter. You have two ways to set a parameter. One is based on the location. So you input your local location where your farm is, and you can select the climate you want, the scenario you want, and model you want, and you can choose crop species and the farming practices here. And or you can also manually input your climate condition. So here you can input your temperature here, precipitation, and potential evapotranspiration here, and also the soil type. And for others are the same. And you will have the result panel like this. And the platform can be accessed through here. So we can go together to check maybe. Yeah, we will wait maybe this one. Yeah, so here is the main page. So basically you can access, here you can know more about the conservation agriculture. Here's the definition and more about the principles and the goal of this project. And this is us. And then you can check, here is the platform, the calculation page. So basically you can change your location and it will take some time to calculate, but in the end, it will show you the probability of yield increase for your selected systems. And you can choose different crops and maybe different future, like in the future climate, you will see. It will take some time. And here you can choose, for example, without the soil cover, without the crop rotation. And if you don't want to choose those things, you can just compare different farming practices. Here you will see many farming practices, and we can see no-tillage or CA with fertilization and with weed and pest control will give you the best performance compared with other systems. So in this way, the farmer can kind of know how to improve the performance of no-tillage or CA systems on their own farm. And here, if you want, you can connect the global map. So I want to connect here, it will take some time. And here it will give you the global performance of CA or yeah, for your selected crop species and under the climate conditions. And you can also choose another way, so you can manually input the climate conditions and the soil types, and it will give you also the performance of CA. And here are also some general information about this project and the papers we used. We included inside this platform and some resources and about us. So yeah, that's all for this presentation. And if you have any question, you can ask or contact me through this email. Thank you.